All right. So, well, first I want to say thank you so much to the organizers. This is just an honor for me to kick off the whole conference. Actually, this was one of my first conferences where I share my research, and I remember sitting all the way there, and I remember seeing that the guys from Outflank actually here talking about red elk, and I was actually working on the elk, right, the hunting elk project, and it was just amazing, fascinating to see red meeting blue and working on similar technology and being able to build something that I understand, right? So that was super cool. And now fast forward all these years, talking about AI and trying to figure out how all the components behind all of these systems will be also used by offense and by defense, right? So the goal today is to walk through some of those components with the concept of agents. Agents are here to stay, right? It's actually a thing that you will have to be very comfortable designing one, trying to execute one, defining what tools you expose to an agent, and how are you going to orchestrate a lot of these systems. But before that, this is, of course, so I work for NVIDIA, but a lot of these things, you don't see any NVIDIA logos. So that's because that's just my presentation directly. So everything I say, right, it's not on behalf of NVIDIA, right? Just putting it out there, right? All right, so the agenda for today, we're going to go through the fundamentals. If you have attended some of my talks before, sometimes I like to spend too much time on the fundamentals, but I think that that's super important. Right? There is a lot of projects that have been released also recently in the security space, but some of them lack of the details that some of that is just basic understanding the fundamentals, right? So hopefully you get that, and then at the end, we're going to be just walking through a few examples of how you can use AI for security operations, and I'll try to do, of course, a defense and offense kind of scenario, and let's just kick off the Agents 101. And by the way, you're going to see a lot of animals. So I'm from Peru. So in the Peruvian Inca culture, we have the puma, the condor, and we also have the snake. It represents heaven, earth, and underworld. So that's what you're going to see a lot of these animals everywhere. All right, so an agent is anything that can actually act on its own and make decisions on its own. When you talk about an agent or an AI agent, it's a system that is capable to do the same thing on its own, but by interacting with the outside world, executing tools, being able to gather information, and using language models today, LLM-based AI agents, to make decisions and figure out what to execute next. The language model piece is super important because that's the engine, the reasoning engine. Some people will say it's not a reasoning engine because it's just predicting the next token to what it is that it wants to reply to your input. But it mimics some of that reasoning where the language model understands language so well that it will be able to say, I can plan what it is that I can do, and the most probable tokens that I will predict for you will generate a plan that you could follow and that you could then get some feedback every time you iterate over the task. So LLM-based AI agents is pretty much where the next, I guess, thing is, and it's something that you have to be super comfortable with, right? Now, the basic idea is that now we don't only have a system that is just going to reply to us as if it's just having a chat-based conversation, right? Now we have a system that will use that language understanding to figure out what it is that we can do. We'll also understand what tools the system has been exposed to and what tools you need to execute in order to continue with this plan that will help you achieve the main goal that you have for yourself and for the agent. And tools are the things that will expose this agent to the world, and we'll be able to gather information and process it. Without tools, this system is just a, let's say, file that has been trained with data from, let's say, year 90 to 2005 or something like that, and then that's the only knowledge that it knows, and it can't access any up-to-date information. So tools allows it to query databases, query APIs, and gather more relevant information. One technique that was actually introduced in 2022, this was a prompt technique, where you would just pass this prompt where you would ask for, can we interact in this cycle, loop of think? I want you to execute something. I want you to act. And I want you to observe what's going on after the execution of something. The way how we were processing this is you would stop the system right when it wants to execute something. You would just stop it. You take that input that it wants to execute, you execute it for the system, and then you pass the results back, making it feel that it actually did it itself. And then the language model wakes up, and it's like, oh, OK, so I already did it. I already executed something, and I'm just going to continue with the conversation. That was what is called today, even though it's 2022. That's like the traditional legacy React loops that you could use to interact with a system in a loop, in this iteration, where you can execute tools. The main components of an agent, of course, is the language model. You also require some type of execution capabilities. You require some capability to store information, such as chat history, so that it could actually continue the conversation with you. And at the end, some type of capability to be able to reason and plan. So a lot of people are building those components, and they are saying, I'm going to build my LLM client generator. I'm going to build my database for all my chat history. But at the end of the day, it's just the same components, right? And there's multiple companies that now are trying to figure out, how do I expose the best database for long-term memory, for example, right? How do I expose the best client LLM so that it could interact with multiple providers that would give you that access to a language model, like OpenAI, Anthropic, Gemini, also through Google and Azure OpenAI, et cetera, right? So let's talk about tools. When someone says, I'm exposing an agent to tools, pretty much what we're doing is we are just saying, you have a tool. Oh, sorry. Go back. There you go. What we're saying is, all you have to know as an agent is that my tool has this name, it has this description, and this is the way how the tool could be called. The parameters, the input. All of this is just plain language that the model has been trained to understand that in this format, the human is giving me context around a tool. What I expect from that model is to simply tell me, if I pass 20 tools and I ask a question that it only needs to use one, I expect the name of the tool, and I expect the input to execute that tool. Keep that in mind. Agents or LLM-based, I guess the model itself, the language model, does not execute anything. It just has been trained to understand that if you pass this payload as part of your request, it knows that you are giving it some capabilities that it needs to figure out which one you need to execute and what the input should be, right? So this is one basic example of the OpenAI Python SDK that you pass your regular message, but then on the top, there is an attribute called tools, where you can pass metadata, the signature of your tool, all the typings, the names, and the descriptions of the tool, because that's what the model will use to recommend what the next tool should be. The reason why I emphasize this is because there is a lot of MCP servers out there that when they define their tools, they don't provide a docstring to the tool. They don't provide a good name to the tool. If you don't do that, your model will not know why that tool is called X and why the description is called testing, right? So just keep that in mind, right? Sometimes we don't understand why do we even care about having some good documentations of our tools and name them the right way. It's because there is a language model behind that is trying to read and understand, why do I need this tool? And if I need it for the question that the human has, right? The way how this works is, as I mentioned before, you pass your message with tools, and now we know the format of the tool, of the payload. The LLM is going to say, this is the tool, this is the input. We, on the other side, are going to take that, execute it, and simply send a tool message back to the model. And then the model is going to summarize everything and pretty much give me an answer. The reason why we don't just stop at step number 3 is because some of those tools that you get access to might give you a JSON payload. it might give you a lot of information that might not be good just to take it and try to figure out what the answer was. A model is supposed to say, this was the question, this was the tool execution results, let me summarize that for you, and let's continue having this normal conversation, right? As I mentioned before, just keep that in mind. That's the only thing that we pass. And the reason why I emphasize this as well is because when we talk about MCP in a second, that's all we're trying to do, dealing with whatever MCP metadata provides to us, and we pass that to our model to execute something. So now, I hope it makes sense that when somebody says, I'm going to build my agentic RAG means retrieval augmented generation, techniques that we would like to use to retrieve context from a database so that I can improve the context that I provide to my model to answer my question. So a tool, I'm just saying, hey, there is a tool that you can use to access extra knowledge that you might not have because you were not trained with this private knowledge. So we have a RAG database with vectors that represent that data. And this is how you would call it, like the name, description, and parameters. So tell me if I need to use that tool whenever there is a question about knowledge that you might not have in your training, that you might have not had in your training data set. This is the one example. There is actually the link at the bottom. Maybe you cannot see it, but this is just a basic MCP server using the SSE protocol. And the way how it works is just an MCP server, all it's doing is taking my tool, the whole tool, right, is defining the code, and it's also defining the metadata of your tool, your function, your Python function, let's say. And when you connect to it, all it is doing is just sending you that metadata, that payload, right? It's just telling you what the name of the tool is. It's sending you what parameters it has, and that's it. That's all you get, right? And then you, as a client of the MCP server, you send that to the language model, and you say, hey, I have a question, and let me know if we need to use that tool. And if we do, tell me what is the input that I need to use to execute that tool. The language model will reply to me and say, this is the name, this is the input, and then we have to send that input all the way to the MCP server, and then the execution occurs on the MCP server. Okay? Even though it sounds out there that, I mean, it's really good, don't get me wrong. This is a really good way to standardize how do you expose tools to multiple people, because all you're doing is simply connecting, retrieving metadata, and simply using it to decide if that's the next tool to use. But at the same time, this back and forth to me, I could easily have my tool locally and just call it, right? Like, why would I have to expose it over there? So just something to think about when someone says MCP. And of course, MCP servers can be used locally, right? At that point, to be honest, why would I even call an MCP server? Anyways, you can do it locally, but then, of course, you can expose it remotely for multiple people to retrieve tool metadata so that then you could ask a model how to call that tool. Let's talk about memory for a second. Memory is the fundamental short-term memory. Says, I'm going to just continue passing all the previous messages in our conversation. That is good for, like, let's say, 10 iterations. But the moment you start going through 20 and 30 and probably 20 minutes or an hour of talking, now you're just overloading the context window of a language model. They do have a limit of how much you can give to them. And usually some techniques would say, stop dropping messages once it gets to this point, right? So that's one technique, right? Or let's pick the last 5, right? But at that point, you're not being as efficient with your memory. There's another way that you could do this. This is called long-term memory. And the way how you do that is now you expose a tool that you label it recall or like save my memory. And then a tool that also would say query my memory, okay? And then something like a graph database, if the language model has been set up properly, it will be able to create a knowledge graph, and it will be able to grow and grow and grow and grow. And what the agent is doing, it's saying, you're talking to me about something that connects you to, let's say, a pizza place. How I know that is because I query the knowledge graph with my tool to understand how I could access memories that are related to you or other contexts of the conversation. Now let's dive into agentic patterns. We talked about this, react, reasoning, and act. The main idea was, let's not just reason, let's actually act so that we can access the outside world and observe what's going on. When you think about this, this is actually the way how I would think about it as a workflow, as a pattern, right? Where there is a question, there is a thought. If there is a tool that needs to be executed, let's act on it. And let's get the observation, and then let's make the language model to figure out what's the next thing to do. And then that loop goes over and over and over, right? Until the language model says, I don't need to execute any tools. I'm just going to answer you directly. And maybe I'll take the chat history to provide a better answer because we executed multiple tools for the past 2 minutes. Let me summarize all that for you, right? So when you think about it, that workflow is technically, when you run it once, it's just a task chain. You can add a loop if you want to continue talking to it. And if you want to actually have this autonomous system doing it on its own, then it becomes a loop. But at the end of the day, it's a pretty basic, fundamental workflow pattern. And it is very important to understand where the language model operates, where the human operates. In this case, is operating at the action level, right? And then where is the environment, right? Which node in your graph workflow is actually representing the environment that it has. And then we have agentic patterns, and this is pretty much taking the basic idea and saying we can add some planning, for example. We can add some reflection, just basic loops. We can keep our tool use pattern, which was the one that you expose tools, tells you which tools to run, and then you continue with the conversation. And then at the end, we have a pattern where you have multiple systems, like the tool use, that are part of a bigger orchestration, right? And they act with their own tools. They might share the same chat history, and they will be able to collaborate if they have sometimes a supervisor on the top. Super cool to see that happening. When someone says workflow, for those that are architects, engineers, they will be like, a workflow is supposed to be very deterministic. It should just work, right? Yes, and that's some of the fundamental steps of agentic workflows, where you're still doing a pretty deterministic loop, but you don't know how that loop is going to turn, like what tools are going to be executed every single time you run it. And that's where the agency, the agentic side of the whole research side comes into place, right? Where you're having a pretty deterministic workflow with some steps that might execute multiple tools, and you might not get a very specific flow. Now, of course, no one is saying that autonomy is the best way to go. There are some workflows that it doesn't make sense to have an agent for. Okay, so that's what I was saying, that some of this, you have to figure out what makes sense in my use case and what doesn't. And at the end of the day, those are just super fundamental workflows, patterns that we use all the time when we build all of these systems. We didn't need to wait for LLM-based AI agents to come to appreciate workflows. And the reason why I say that is because there is a lot of tools that are actually building their own workflow engines when there is already so many different workflow engines out there that have figured out what's the best way to execute steps in a production environment, right? So something to think about, right? That you will be defining task chainings, fan-outs, fan-ins, loops, etc. when you start building a system. So you have to figure out what's the best tool that would help me to define the right workflows that can be durable, for example. A durable workflow means that when you execute 20 tasks and you failed at the 19th task, you don't want to go back to task number 1. You want to keep the state of every single task so that you can resume from where you failed at. That's a durable task. And there is some frameworks that don't have the capability. So if you're trying to take something to production, maybe that's one question that I would ask, is this durable or not? Now we're getting into some of the patterns where you see now agents that could collaborate across, let's say, having some type of router that would say, I am capable to analyze malware. I'm capable to maybe query a threat intel database. The router would say, well, the current state of our operation, it's calling for some analysis of a file. So let me route this to the actual agent that has the right tools to execute something. Now, how do you provide that context? You need to provide the right name to the agent. Don't just call it Bob, right? You might call it a reverse engineer agent. You might give it a description that will say, this is the person, or I mean, the AI person that will do the job for you, right? So it's super important to keep that in mind. The other one is the supervisor, which is the one that I've used the most, to be honest. So that's the one where you have a supervisor that is interacting with the human, and that's the one that is also doing some of this routing. And the agents know that they just have to reply to the supervisor, and the supervisor is the one that will keep a to-do list of things that are happening, which is actually one technique that you will need to use when you try to build this type of systems. I will highly recommend not just to say, let's just throw it to the model and figure out what's next. I would recommend to have some type of JSON object or maybe a database where there is a state that you can retrieve and constantly check what have we done. And if there is 5 tasks that still need to happen, then let's push for those 5 to be analyzed, right? Rather than just having a loop where I just continue pushing things to the model. The other one is, of course, that you can have a same concept of a supervisor, but instead of having the task to supervise agents, now you're supervising teams of agents. And so that starts becoming a lot crazy, but it's still supervisor. The supervisor, all he has to know is that I have 2 teams. One is the dev team. The other one might be the team, I don't know, that is already taking things to production. So whenever somebody talks about production, I got to talk to this team. And then the team will have to also figure out how they delegate all of these tasks to the other agents, right? So pretty cool concepts that are very interesting to dive into and figure out what makes sense or not. So with that, we have concluded our fundamentals, and we still have 20 minutes, so that's great. So the way, to me, when we start thinking about AI for security operations, the first thing is to figure out, in my opinion, what are the things that you will require from these systems, right? What are some of the tasks that there is already some people doing them? And just define what it is that I would love to maybe create as well. So for example, the researcher piece happens on blue and the offensive side, blue and red side. But usually it's not considered to be honest, with some teams, it's not considered a position. You're just left to do research whenever you have time, right? So yeah, I see people, yeah, see, that's exactly what happens. So you're just left to do that whenever you have time, and it doesn't become a thing. But with the rise of agents, you can start defining, we need to have a researcher querying databases out there, maybe searching the web every day just to gather information so that we can review it every morning. So you start defining those type of personas in your team that you cannot afford maybe, or that it's just not a thing because nobody has time for doing all that. The reason why I put it in this way is because at the end of the day, we all have the same issues. And the reason why I say that too is because I've actually worked with the red side of the house too when I was at Microsoft, where we were trying to define how do we enable autonomy for those teams as well, not only the blue side of the house, but also the red team. And at the end of the day, we have similar issues. One, you need to be able to summarize what it is that is being presented to you, right? This could be for a security analyst. It could just be multiple, maybe alerts, multiple documents that it needs to process to make a decision, should we investigate or not? But then you do the same thing if you have a ton of data that you need to review as a red team operator as well. You need to be able to prioritize things. You need to be able to pivot, for example. And this is why tools like bloodhound were built, because you need to know how to pivot, right? Well, we also need to know from a security analyst perspective, we need to know how to pivot from one data set to the other one, right? Sometimes we're exposed to multiple data sets that have multiple schemas that we've never seen, and we just need to figure that out in 30 minutes because we have a debrief that needs to happen, right, to the CISO, the CEO. And then at the end, we all need to gather the right information, right, to make a decision. How do you augment this whole retrieval process? We have the same issue. It's just different sources of data sometimes. And then, of course, at the end, something that I've seen teams now building in-house is post-training teams, which means how can we optimize all of these models, language models, that we are being exposed to so that we can transfer knowledge from our security experts, right? What parts of my operation requires a specific model that it needs to be as good as the person that you usually call when things go terribly wrong, right? You need to do that. So there is already some of those challenges that you will be facing. How do you transfer your knowledge? How do you fine-tune a model to have some type of a standard, even to how do you produce simple things as even how you produce a report, for example, right? Anyway, so that I hope is clear. There is no red and blue here. There is actually, you're going to have the same challenges. And by the way, I'm picking challenges that will help, let's say, challenges that will help you tackle if you're trying to build an agent that will interact with data that comes from an engagement that you, let's say, execute. And from the offensive side, let's say engagement, of course, on the security side, is the same thing, engagement to investigate an alert or an incident. You're dealing with data, right? You're capturing so much data. There is a project from SpectreOps, Nemesis, right? And we have also Lee Christensen and Will Schroeder in CIFCon. And I love that they also think about data. Like, that data is super important to drive what the next thing is. Well, there is a lot of challenges that agents will face, right? And also agents will help you in some of these areas. And of course, I mentioned earlier, even the outflank guys, when they talked about Red Elk, that's data. They're capturing as much data as they can so that they can also see what's going on across their operations, right? So data, super important. All right. So the strategy, if you're trying to build these capabilities in-house and you're trying to present this to someone in your organization, the way how I would organize these thoughts is that don't just say, let's build agents. Let's just agentify the whole thing. Doesn't work. It's super fun to talk about it. You're like, oh my God, we can do all these cool things. But in reality, there's a lot of things that we can just augment. There are a lot of things that we could just say, there is a 2 steps workflow with an LLM that would allow you to get better at summarizing your data, get better at keeping track of incidents, like the incident scribe, or from a red team perspective, the keeping track of all the findings and trying to build a report with all the knowledge that was shared across the whole engagement, right? So there are a lot of things that you don't need an agent, right? So this way you could say, let's try to figure out where we could augment some of these things. Let's then figure out what makes sense to automate, not from a, of course, SOAR perspective, but more so that from the agentic side of the house, where some of these workflows cannot just be deterministic. There needs to be some decision that should be taken by an agent, right? And here is where you need to emphasize, in my opinion, today, we still need to emphasize the concept of human in the loop. And human in the loop is not just to accept and approve every single step of the agent, because that's not feasible. But there are certain tasks, such as, for example, in the blue side, that you cannot just let it today block your whole, any endpoint that it believes it needs to be blocked, right? There are things that you can do, but there is a lot of things today, like tier 1 alerts, that thing should be automated. So when you think about where the human is, it's not the same across every single challenge that you will face. When you define the levels of autonomy also in your organization, because that's a big piece too. You need to define what level are you trying to achieve with the system. And believe me, there is not a standard to say, these are all the levels that you should follow, right? Every organization defines what it means to be in level 1, level 2, 4, and 5. The way how I see it sometimes is level 0, of course, no autonomy. Level 1, we're talking about we're having a system, like, let's say, just being told what to do, but it's really good at retrieving data. Level 3, to me, is like, all right, you're going to be part of the hunt. Let's go together. I'm going to let you do some things on your own, but you still, I'm still guiding the whole thing, right? Level 4, to me, is when now you move towards a more, I'm going to write policies to make sure that you're aligned. I'm going to make sure that there are not going to be areas where you could just mess up and cause harm. And I'm going to just be sampling the reports that you generate from an offensive, from a defensive perspective. I'm going to sample some of those and just evaluate them, right? And of course, level 5, God mode, right? Which, who knows, we might get there next month or something, right? with all of these things that keep changing. Didn't mean to change it there. 1 second. There you go. And then the last 2, super important. That's the part sometimes that people don't think is the fun part, but it is the fun part to me. Seriously. Being able to figure out how to optimize the models and talk to the experts to say, what can we do here to make it better? Can I gather a lot of chat sessions that you have had with somebody else during an investigation? Can I get all the queries that you have run before so that I could make the system more aware of what are the types of things that it can execute? What behavior do I want to enable? Super cool. And there is a lot of teams that are actually focusing on that only. The last part is evaluations. This needs to be done since day 1. Evaluation should not be done when you're about to release an MVP. An MVP is supposed to then be exposed, right, to folks to provide feedback. You don't want to start evaluations right there. An evaluation could look like something as simple as, I have a system. I have exposed my system to a database where data exists that I want the system to use. And I'm going to ask 10 questions. 10 questions are going to be answered by the system that was able to access the database. And then I'll simply review it and be like, this doesn't make sense, this makes sense. And then you're going to start identifying where some of those issues are. It could be initially time-consuming when you start setting it up. But then after that, you can start using some other techniques where you rely also on other models that are a little bit more expensive but are better at processing information. And they are the ones that could expedite a lot of this evaluation as well. And evaluation is also where you start truly tracing. You start actually getting a lot of traces that have been captured of the agents running across your organization. And when you capture that information, it's super fun to be able to graph all of that, to see how it is communicating, what actions it is taking, for example. Did it actually come up with 3 steps that we never even thought of, for example? That's fascinating to me, right? So think about this. There is, for example, a couple of APIs that have been used recently by threat actors that they just figured out a new way to export email data. And I'm like, can you just get a system to traverse all the open API specs of all the Microsoft Graph APIs and just go with it for like a week, come back and tell me what connections make sense? That would be cool to do, right? I can't do that. It's just too much data, right? And then at the end, when you build a system, all of these capabilities that we talked about initially to augment something can become some of those tools. That's what I say. Augmentation and automation. You can start with augmentation, but at the end of the day, you want the system to use those capabilities. It could be a microservice, for example, that allows you to summarize something the right way. Then it becomes a tool for the agent. You need to expose the agent to organizational, institutional knowledge. This could be from a defensive side. This could be, I want to expose it to all the cases that people have done. And of course, from an offensive side, let's say something like from Nemesis, from a Red Elk, where you could gather all that information and say, now I know how something similar happened in the past. I could probably act on it, right? And the idea is that you will start building initially a lot of agents that are kind of like very general agents. For example, from the defensive side, you would start with, I'm going to build a stock analyst. and let's build the best stock analyst that has existed in the company. But then you realize, we just need to build a phishing stock analyst first. Then we need to build an EVR stock analyst next, because you realize that there is just so much to cover that specializing them on something would allow the system to capture the right context. It won't have to figure out all the 100 different tools that it has access to, right? And now we're going to dive into some of these workflows in general, where everybody is trying to do this. It's trying to graph their data. It's trying to say, everybody, push their data. Let's graph it, and let's have an agent start communicating with it. I guess, it's feasible, but it's super challenging, right? So what we are expecting is an agent to just say, everybody has agreed to have an ontology to graph the whole world. Now everything is in a graph. That's amazing. I hope that happens, but it's really hard to do across all the data that exists. So the idea is that what if we have a system that when you send it an alert or anything that it triggers, it reads the alert and it says, OK, based on this alert, there is 20 data tables, schemas, that I need to probably look into. Let's build a graph of those schemas first. Those are only 20 files, let's say. And then let's use our coding capabilities to code an ETL job to then retrieve data that has been structured and unstructured somewhere, and then be able to graph it. And now you look into this scoped side of the graph with an agent that did not process hundreds of thousands of events. It only processed data schemas to understand how they would connect, and then be able to ETL the data back. And then as the system iterates, there's going to be questions from the analyst, and the analyst would say, you know what? Now I think that I need to start looking into some process creation, or maybe some permissions, or consent being granted in this environment for a service principal that existed in a different tenant, for example. Then I want the system to say, OK, cool, just give me 1 minute. I'm going to go back to my tables. I'm going to say, OK, I need to add an extra 10 tables. So I'm going to do the same exercise. I'm going to graph those 10. I'm going to look at my current ontology and be able to merge that. And then simply say, can we run an ETL job so that we can upsert all this data again? And you will be surprised how good it is at doing it, because don't ask me how an ontology can be created in a couple of seconds, but if somebody or something is creating it for me, and the moment I ask question, is traversing it the right way, it's because the model was able to graph something that it believed that's the way how it should be graphed. And I'm not going to criticize my model to what it needs to graph. This is going to be an assistant now. So switching to the, I would say, offensive side of the house. This is a system that it has access to Bloodhound through an MCP server. And then it also has access to a knowledge graph on the side, so 2 knowledge graphs, where it's going to be tracking my questions. It's going to be tracking all the things that I'm doing. It's just like me talking to a friend, kind of working on hey, let's run these tools, let's do that. I found this, I found that. But the system is collecting all of that information. So let's do that. So let's just, I think everything should be running properly, so hopefully. So in this case, what I'm doing, I'm going to make it bigger, so probably that's better here. So what I'm trying to do is simply starting an episode with my assistant. Hey, I'm Roberto. I'm working on this operation. I'm a red team operator, and I would like you to assist me because I'm assisting other red teamers with access to Bloodhound database, right? And the first step is going to be to generate a node that is going to capture me as the center of the node. And then at the end, it will be able to connect everything that I did, so that then I can generate a report. I can also figure out where I could go next. Because when you are interacting with Bloodhound, you're also building your own graph on your head. Because now you know, I have this, I have that. Yes, you might have a console that might show it all that to you. But it would be nice to have something that is capturing not only my queries, my output, but it's also capturing my intent, my reasoning, my questions, right? All right, so we do that. We expose this, set up the MCP server, give it a prompt so that, hey, you're going to be helping me. And then at the end, this is the basic graph that gets created that is going to be ready with all of these tools. And then I'm going to say, I'm working on an op 1001. And let's see what it does. And it says, can you provide more details about, I'm going to show you the message here. Can you provide more details about this op specifically? I need information on the scope and target. It's asking me too many questions. I'm like, OK, you don't have to know any of that. OK, you just kind of assist me with some of the things, like running a query for me. I'm looking for a list of 5 users in the organization based on the posture graph that we have access to. And now, I'm having some issues with the authentication, so we don't know if that's going to look. Oh, it did. Nice. OK, that's awesome. So what it did, it actually, this is super crazy. I love it. This is, it's using multiple tools, and it's saying, this person is asking me for, can we traverse the graph? But at the same time, I know that I need to keep track of all the memories that this person is generating while traversing the graph. Right? So it's deciding, I'm going to execute the tool first, then I'm going to execute this tool to capture memory, I'm going to push it to the knowledge graph, and then I'm going to keep that memory available for the following operations. Right? So now if we go and check the graph, for example, and I only have a few more minutes, but let me just do this real quick. I have to save my cipher. You see, I've been using this so much that I already forgot cipher. That's how crazy these things are. And anyways, so you can see that right away, this is not my bloodhound database. This is just my assistant that it's saying, and of course, I'm limiting it to 5 only, right? 5 things in here. But in here, I'm just saying that I want you to keep track. I want you to be my assistant, scribe, as I am running an operation. And you can see that it's saying the investigation that this person is part of, these are some of the people that are mentioned, right? Something like that. And of course, if we go to Bloodhound, there's going to be all the data that it's using, right? So that's one example, and you can continue talking to this thing, and you could continue giving it more facts. You can even ask what cipher queries it runs, so that way you can start figure out, I guess, what it is that it's doing. And I guess he just told me that it ran that one, for example. And this MCP doesn't have all the tools that you can possibly run with Bloodhound. There is actually an MCP from SpectreOps that has all the tools. I'm trying something different. I'm trying to say, I want you to read the schema very well, and there are actually models that are good at it. And once you learn the schema, I can ask any question to you. And I'm expecting you to be as efficient as all the people that contributed, all the 30, 40 different queries that exist out there. Of course, I can use those queries as a little bit on the side so that I could have them as a reference. If you don't know how to run something, maybe check the references, and maybe you will learn something new, right? And then we have the personal incident scribe, which it just does the same thing, as I'm kind of running a little bit of time in here. It just does the same thing. I'm part of an incident, and I'm simply interacting with this incident, as you notice in here, and it's just capturing. When you talk to an incident responder, I actually had the privilege to work with John Lambert from Microsoft, from Mystic, and when he explains how he's thinking about the threat actor, you see his wall and some of the papers that he puts in his house, and it's just a knowledge graph. It's just saying, this happened, and this happened here, and then here and here. And then I'm listening, and I'm like, OK, that's great, but I'll forget in the next 2 minutes everything that you talked to me about, right? I want something that is running with me so that it can continue building all these memories, and it's able to retrieve those memories whenever I need them, right? So that's going to be a project named Graphiki, all right? Graphiki, stay tuned. It's something that will not just say, oh, this is for blue or red. It's just going to say it's capable to collect memories. It's capable to respond to the human by querying their own knowledge graph, and you expose it to any tool that you want it to expose to. And then it can work for offense. It can work for defense. And I'm just sharing the underneath the components that work for both sides of the house. And the last one is going to be, I built this workflow that allows me to read papers from ArcSIF which is something that you will be getting more familiarized with, because a lot of the research that happens on the offense and blue, any type of AI, I guess, you will find a lot of papers there that are super interesting. So I don't want to read papers. My level of attention, it's like only 2 minutes on a paper, and then I stop. But I pay attention when I run. So I built this workflow to download papers with the right search keywords, and then I'm doing some reflection loops to make sure that I'm capturing the right papers. And then I go through this generation of podcast dialogue, and then I simply, I clone my voice so that I could actually listen to myself while I'm running. So it's just me talking about, research papers in security. And you guys are the first people in the world, besides my wife and my brother, that know about it. So there is 2 episodes, okay? This is my podcast, and I always wanted to have a podcast, but I'm not that good in front of the camera. I'm good talking to you guys because I can't see anybody, right? I don't have a good side all the way there, right? But if I'm sitting with a camera, sometimes I'm not that good. So it's good to actually have it, do it all for me. So think about that. Change the argSIF kind of like queries and point it to the database that you're constantly trying to read from. And if you are someone like myself that likes to run and listen to things, and that's how you start your morning, that will be your security researcher every day or every other day, giving you a summary of what's hot, what you can do. And if it keeps your memories, how I show you how it does it with Bloodhound, then it will be able to tell you, by the way, you talked about something like this last week, and this paper talks about how you can probably approach that thing. Fascinating world that we're living. Thank you so much for your attention. This was an honor to be part of this conference and kicking everything off. I hope you have fun in the whole conference. Try to figure out what makes sense for an agent to do as well, right? So you might have an assistant always with you. Maybe, who knows, next year you come to CIFCon and you're already kind of working with your own assistant on the side. But thank you very much, everyone. Enjoy your day.